So today's lesson is about the difference quotient. Okay, so what we have here is a graph. Maybe this is a x squared type of a graph, right? Doesn't look like it crosses the x-axis, but who knows? It's just a graph, right? Let's don't split hairs about what the graph looks like and all of its intercepts and such. But we are going to want to find, or you are going to be asked to find, the slope of a line that is tangent to the graph at a certain point. Right, so this is your x value that we want to find the slope of the tangent line to. And of course, every x value has a y value, which in this case we call f of x. Okay, so we are going to find the slope, or rather estimate maybe, the slope of the line at this point. Okay, so to start doing that, we need to pick some other points. Okay, and I'm doing this exaggerated. I'm going to go h units away from x. So this is an arbitrary number h, right? So then this x coordinate over here is now x plus h, right? I've gone x units from our origin to here, and then I've gone h more units. So the x coordinate here is some x plus h, right? And these would be numbers if I told you what x and h were. So if this is your x coordinate, then it is, of course, matched with another y coordinate up here, right? Directly above it is the y coordinate. And this one is f of x plus h. Right? So each of these points have an x and they have a y. So let's write it a little bit more formally. This has the coordinate x, comma, x, f of x plus h. Rather, that's not right. Let's go back. All right, I need to do some erasing here. Let me move over. Okay, this sounds better. So this point is x plus h, right? That is the x coordinate from down here. And the y coordinate is f of x plus h, the y value for this certain x value. And our blue point down here is just x and f of x. Right, those are the coordinates. So if we were going to draw our line, right, the slope of the line that passes through these 2 points, it would look something like that. Okay, so now this is called a secant line because it has 2 points of intersection on your graph, right? It crosses your graph in 2 places, so this is a secant line. And if we want to write the equation of this secant line, the first thing we would have to do is find the slope. Okay, so our general slope equation is y minus y over x minus x. So this is how we're going to build our difference quotient, finding the slope of this secant line. Okay, so we take the y value from our green point, which is f of x plus h, and we subtract the y value from our blue point, which is just f of x. So y minus y over x minus x. So the x from our green point is x plus h, and your x from your original point is just x. Okay, so this looks pretty good. I can do 1 part simplification and subtract in my numerator. X minus x is just 0. So then I am left with this for my slope. F of x plus h, that y value, minus the original y value over just h. Okay, so that will tell us the slope of this yellow secant line. Now, can you imagine in your brain, and if I had some other software, it would be neat, but if I took this green point and I started moving it closer and closer and closer towards my blue point. Okay, if you can imagine that happening, the h values are getting smaller and smaller and smaller and smaller. Okay, and in calculus, we call that taking the limit as h goes to 0. Right, so if our h value, the distance between our 2 points, gets smaller and smaller and smaller and smaller, then this yellow secant line becomes a better approximation of the slope of the line exactly at that blue point, or the tangent line. Okay, when h becomes 0, when it gets infinitesimally close, we now call that a tangent line. It will be touching in exactly one place. Okay, so that's how we derive this difference quotient that we're going to use in order to start finding the equation, or the equation of the slope, the equation to find the slope, rather, at any given point on our graph. So let's use this difference quotient to do some calculus problems. That needs to change with it. Change everything. There we go. So here is a linear function that we're going to use the difference quotient on in order to figure out what the slope is, or the equation that we can figure out for all of these values. So remember, we're going to first replace x with x plus h. So that's 2/3 of x plus h plus 3, right? That's your original. Right, so we're taking the limit as h goes to 0. There's f of x plus h minus f of x, which is 2/3 of x plus 3, all divided by h. Okay, so the first thing we have to do is some distribution. So 2/3 times x and 2/3 times h.
Why do we add that minus 2? Because that's f of x, the formula. I got you.
Okay, and that's our first little function, 2/3 of x plus 2/3 of h plus 3. And now I have to distribute my minus into my second equation. So minus and minus means I have a minus 2/3 of x minus 3 all over h. So now I can look and think about things that will cancel. So here I have, this one will cancel, 2/3 of x with the minus 2/3 of x. And my positive 3 will cancel with my negative 3. So I'm left with a pretty simple equation. The limits as h approaches 0 of 2/3 times h divided by h, which the h's will cancel out. So we're basically left with just the limit as h approaches 0 of 2/3. And if we take the limit of a constant, that is always just a constant. So the limits, or rather the slope of this line with will always be 2/3. Right? No equation. This is a constant slope of 2/3. Okay, that's what we get when we apply the difference quotient to our linear function. Okay, so find the equation of the tangent line of f of x at x equals 3. So if we want to write an equation, we need to know two things. We need to know the slope, okay, and that's this, right? The difference quotient will tell you what the slope is. So the slope of that line is 2/3, and we need to know the point. Okay, so we know the x value at 3, but what is the y value? Well, the y value is 2/3 of the x value plus 3. Right? 2/3 x plus 3, which is 2/3 of 3 is just 2. 2 plus 3 is 5. Okay, so I have a slope of 2/3 and a point of 3 comma 5. So we're going to write this in point slope form, because in AP Calculus that is good enough. You do not have to simplify. So y minus 5 equals 2/3 of x minus 3. Okay, and that is our equation of our line at x equals 3, because the y value is 5 and the slope is 2/3. So let's practice one more time with a little bit more of an intense equation that I'll put up right now. So we have 1/2 of x squared minus 2x plus 3 is our function that we're going to find the equation for the slope of the line. So in other words, the derivative. First we do the difference quotient. Okay, so we've gotten to this point, right? This is some pretty serious algebra. You really got to keep track of the things that we are looking at and how we're multiplying. But now we can do our canceling. So we have 1/2 of x squared minus 1/2 of x squared. We have a minus 2x and a plus 2x. We have a plus 3 and a minus 3. So all of those things are able to cancel out, and we're left with just one equation with h. Okay, simplifying that all down gives us the limit as h goes to 0 of x plus 1/2 of h minus 2. So now we can do our direct substitution, and we get the
Wait, Mr. Richard, whenever you...
Okay, so we did all of that work to find out that the derivative or the equation for your slope at any point is just x minus 2. Okay, remember the derivative is the slope of the line, or rather the equation to find the slope of the line at any given x value. So now that we know the equation, x minus 2, we can come over here and find our equation of the tangent line at x equals negative 2. Okay, so remember the two things that we need to write the equation of a line. We need a slope and we need to find the points. Okay, so the slope is the first derivative, or f prime, at negative 2. Right, because our x value is negative 2, so the slope at negative 2. And our point is negative 2 comma f of negative 2. Okay, so we need to differentiate, right? This f prime means slope. This f of negative 2 means y value. So to find the slope, we'll use the f prime equation, and to find the y value, we'll use the original equation. So this is what we calculate for our x value of negative 2. We have a slope of negative 4, and we have a y value of 9. So to write the equation, we plug in our y value, your slope, and your x value into this equation. Okay, and when you do that, we get y minus 9, because that's the y value at negative 2, equals negative 4, that's the slope, times x plus 2, because that's minus a negative 2. So this is a perfectly wonderful equation for the slope of our line tangent to x equals negative 2.
Have a good one, Mr. Manchester.
Okay, so all that comes from the difference quotient.